upload their talk, so.
Okay, thank you. Okay, so first of all, thanks a lot for inviting me to this workshop. Actually, I don't work a lot on historical data, only when Miguel asked me to do that. But I do work a little bit in the interface between science and policy and how science can better inform spatial planning and so on, mostly at European scales, but also at national scales. So I would like to give only a couple of ideas of what I think it is important when we want to translate historical data into some useful products for policy. So I think in the last years we are experiencing kind of a shift in the conservation ambitions globally and also at the European level. I really like, you all are familiar, of course, with this famous curve of Mays and co-authors of blending the curve. So traditionally, how international agreements on biodiversity conservation and so on have worked, they have been very reactive. Yeah, so they have been using narratives about trying to halt the decline of biodiversity loss, try to integrate better activities, human activities, with nature in order to try to reduce that loss of biodiversity. This is what actually motivated the first agreements of the CBD under those very reactive narratives. Over the years, different targets have been proposed or agreed at the global level related to how can we actually try to minimize the decline of biodiversity. Last one was the IKI targets, the famous IKI targets agreed on 2010. And it is widely recognized that despite all the efforts or despite of all the agreements, in reality, we never were able to meet most, if not any, of those targets. So recently, there has been a strong push to try to reverse those narratives. So being, instead of reactive, being proactive, being translating the message of, okay, it's not only that we need to stop biodiversity declines, we really need to restore nature. We need to set aside part of nature just for conservation, and in addition, recover nature in all places, places where we live, in cities, in countryside, and of course in natural areas. This is very well reflected in the last global agreement, the recently approved Global Biodiversity Framework, the Montreal agreements, where in Goal A, for example, we can read that the integrity, connectivity, and resilience of all ecosystems are maintained, enhanced, or restored, substantially increasing the area of natural ecosystems by 2030. And there are some important wording here. So this may look like just big commitments, but there is wording here that is very different from before, like ecosystem integrity, connectivity, and resilience of ecosystems. And then there are those big goals, which are goals for 2050, are breaking down into targets for 2030 that follow more or less the same philosophy. Here in Europe, we have also, since the last European Commission is in place, we have been also seeing a very strong push for increasing the ambitions of conservation of biodiversity. So, for example, the famous 30% target of protected areas. That is, there is a compromise that member states of the European Union need to increase the area of protected nature by until up to 30% of the cover of the country. But even more important than that, because we are in reality very close to that, more important than that is this 10% target of integral protection. So protecting areas in a way that actually can provide integral ecosystem functions. There is a whole new battery of policies that are under development or we expect to be approved soon related to the European biodiversity strategy. One of them is, for example, the nature restoration law, currently under discussion in the European Parliament and also in member states, that says that, or mandates, if it is approved, that 20% of the land of the European Union needs to be under restoration by 2030. And again, those important words are enhancing habitat condition, which is kind of a different name that the European Commission uses for ecosystem integrity, and connectivity. Okay, so this is kind of an overall setting of policies that aim to restore ecosystem integrity, but what we call ecosystem integrity. And of course, this is a very broad concept. I'm going to focus, since we are speaking about species distributions and so on, I'm going to focus on one of the key aspects that I think need to be considered on ecosystem integrity, which is restoring integral communities of animals. And because of my background and my interest and so on, focusing very much on large animals that are providing important ecosystem functions, such as large predators like aerial lynx here, a critical endangered species until recently, now only an endangered species, but that is also involved in trophic cascades, as many other large carnivores are. Large herbivores that have disappeared from most of Europe and also from most of the rest of the world, which actually play very important roles in controlling natural vegetation dynamics, but also others that are not so often considered as species providing ecosystem services, like, for example, vultures in this case. So scavengers are able to remove up to 25,000 tons of carrion per year, only in Spain. And there are some other important ecosystem functions that large species play, some of them not very well known, but more and more evident now. Like, for example, the capacity of a species like the bear to disperse fruits and then also modify in this way the vegetation structure. Now, if we look at this map of Europe, this is an index of what I like to call trophic integrity. This is kind of the departure across Europe between what would you expect to be the trophic integrity in each of the 10 by 10 cells in this map from what would be expected to be the trophic integrity in that cell. And trophic integrity here is calculated as the difference between the current community composition of large species and what would be there if human influence wouldn't have happened. This map is constructed based on some assumptions. So one key assumption is the species could be able to be in those ecological units, in those environments where the species is today or has been there for the last 2,000 years. I can give you more details later if someone is interested about this kind of analysis. And one of the results that we immediately see is that only about 5% of the area covered by the European Union preserves or has recovered more than 50% of the baseline functional diversity. And there is absolutely no one single square that preserves all the functional diversity looking at those communities. These kind of approaches have been used for defining global priorities for restoring intact communities. So this is this is a paper led by Carly Biene last year in ecography, where we analyzed the current distribution of species, of large mammal species across the world based on IUCN range maps compared to potential distributions as well, and we identified for each of the biogeographical regions of the world which communities, which of those regions are closer to full integrity of the communities, and then trying to prioritize where reintroductions could be made in order to optimize the recovery of that ecosystem integrity. Still, the problem with all those approaches is that the underlying data is mostly based on species range maps. And species range maps most often are either exclusively delineated by a group of experts, or they use some kind of combination between expert-based assessments and some underlying data. And this is not only for, this is of course the case for current data, or the current status of the distribution of a species, but when we speak about past distributions, for example, the maps that are in the IUCN comparing the extinction or the contraction in range maps from the 1500 to present day, the situation is even more uncertain. Yeah. So you can see here that according to IUCN, in Spain, in the 1500, there were bears all in the Pyrenees and in the Cantabrian Mountains. Most likely this was not the case. Actually, it was not the case, as Duarte has shown this morning, right? And you can see all those very funny shapes there that probably just connect some point where there is some kind of citation lost there with big masses of distribution areas. The second source of information that is very often used as baseline information for species distributions are archaeological records. And this is a paper published a few years ago by Chris and colleagues in Proceedings, where they collected data from archaeological records across all Europe. And here again you can see a couple of pictures of how the distributions could be in the early medieval times and late medieval for the Eurasian bear. Sorry. So you can see very clearly that, well, those kind of range maps are strongly affected by outlier observations, even in areas where we know that the species was clearly there. So what can we do under this situation? Well, in many occasions, probably not much. I hope we can clarify a little bit during this workshop. But in some cases, it is possible to do some things. And I'm going to explain the results of two case studies here in Spain with two charismatic species, the brown bear and the wolf. Those are studies that we are doing together with some colleagues of the Doñana Biological Station, with Miguel Clavero and with others, where we are able to analyze distribution data at high density, at high spatial density, in order to develop models and be able to, from those models, estimate what has been the contraction range of those species. And this has policy relevance, as I will explain later. And I want to focus very much on this approach to mesoscale predictive modeling, because I think that looking at those mesoscales is particularly important when we want to make recommendations for policy. With mesoscale here, I'm referring to scales to a spatial extent and resolution that can allow you to actually identify extinctions at the population level and not just large range contractions and so on. So one of the sources of information that we use, I'm going to start with the brown bear. The first source of information that we used is this Libro de la Montería. It is a book from the 14th century of, that is imputed to King Alfonso XI. So, but probably it actually compiles information that comes from some years before. So we could say that this is more or less like the aggregate situation by sometime in the 14th century. And this book, actually, it is a collection of 3 different books. One of them contains very detailed descriptions of where this king went for hunting. So this king was in summer, he was fighting against the Muslims, trying to reconquer Spain from the Muslims, and then in winter he went for hunting. This is what he did. And in those descriptions, so he mentions the name of the area, like the name of the region, the specific name of the place, and even in the mountain, so from where he was approaching the area with the dogs in order to hunt either bears or wild boars. And then there is a very long set of descriptions across many different mountain ranges in Spain. And for example, he would say, well, this mountain is particularly good for hunting brown bears with cubs, or breeding brown bears, or this is only good for wild boar. So we have a very nice situation of presence-absent data, yeah? So this is the guy, this is the person of interest. In reality, this picture is from much later. I was not able to find a picture from that time. And this is what actually was Spain at that time. So in reality, this data set is not for Spain, because Spain didn't exist. It was for Castilla, which is what is outlined in red. And just to put a little bit of perspective, I like to show this picture to put a perspective of what is the importance of this kind of data in historical terms. So this is, those data sets come from 1350 approximately. Only 150 years later, Columbus did their first voyage to the Americas. And only almost 500 years later, Darwin wrote The Origin of the Species. So this gives like a perspective of what time we are speaking about here. And with the help of the non-agreed help of José Antonio Valverde, so he was a very famous Spanish ecologist that used this book to make holidays every summer and then try to identify exactly those places. We are today able to map each of those locations of this book in a quite precise, I would say, 5 or 10 square kilometers resolution. And then we can have a presence-absent data very similar to what we would have today, even better than many of the presence-absent data that we have for some countries today, even in Europe for this species. Now, what do we do with this data? Of course, this is not enough to give us the information about what was the distribution of brown bears at that time, but what we can do is to use that data together with models to try to predict where the species was. And there are many different approaches to that. In this case, we wanted to follow a more hypothesis-based approach, where we tested whether land use would determine the distribution of brown bears by that time. Now, the problem, of course, we don't have Korean land cover data today. We don't have remote sensing data for that, those ages and so on. So what we did was to use a kind of model that is quite often used for example, in reconstruction of forest distributions, which is based on the suitability of the land for cultivation, or the suitability of the land for farming, no? for livestock. So what those models do is to relate the suitability of the land with climatic variables. So those are the growing degree days, and one indicator, this is a Priestley-Taylor alpha, which is one indicator of evapotranspiration. So this is, what it does is that it sets the cold limit and the dry limit of the distribution of agriculture, and then you can relate this with the probability of agriculture. And then there is the second group of variables, which is the suitability of the soil for agriculture, which is mostly determined by carbon content and pH. So we fitted those models using contemporary data, actually, but then what it gives you is kind of an overall perspective of how suitable is the area for agriculture if modern technology was not there, yeah, was not in place. So those are the predictors that we can calculate from them. One is climatic suitability for agriculture, another is climatic suitability for pastures, and finally overall suitability for land use. So this is kind of a temporal data set of probability of land use that we used for making those predictions, and we combined that with other determinants of brown-bear distributions that are well known, such as, for example, the difference in elevation and so on. So this is the predictive map of the habitat distribution of brown bears in the 14th century. I would say the fit of the model is not too bad, considering all the limitations. And it gives us already a picture of what was the suitability of the habitats across Spain, which in reality is not very different from pictures or from maps of the current suitability of the habitats for the brown bear also in Spain. So here to the right, this is a paper from a few years ago where we compared different habitat suitability models which were based on very fine scale and fine resolution data of brown bears, and also, of course, the contemporary layers of habitat variables, and many of the areas that were predicted as suitable today were already suitable at that time. So we can say that the brown bear was present all over Spain, and it disappeared and was constrained to the areas where today is present, not because of habitat constraints. Actually, those habitats are still the same, or some of them are still the same, but rather because of other processes. We can use other sources of information. I think you have been already speaking about the MADOT, this dictionary that describes localities in Spain and provides a lot of information on agriculture, species, and so on. And there is also information on brown bears. So this is the distribution in the 14th century according to the King Alfonso XI. And this is the distribution already in the 19th century according to the MADOT. So most of the populations of Spain were already extinct. They persisted all in the areas that the species is still today. And then you can compare the distributions, you can model those distributions, and we found that in reality when you use the same variables of the models for predicting agriculture, in reality the models don't get much better than when you use, instead of that, remote sensing information or contemporary information on land use. So the area under the receiving operating curve here was already as high as 0.93. It means with those variables we can already predict very well past distributions of the species. Okay, so how much time do I have? Okay, not much. So why does all of this matter? So first of all, I think that historical perspective of the species vulnerability, those kind of models actually provide you information about what were the constraints or the most likely constraints at that time already for those species. And apparently in that time, in the 14th century, the same constraints were in place as today. So land use was mostly the main driver, most likely, of the distribution of brown bears already in the 14th century. But not only that, those model-based approaches can provide much higher resolution and more precise historical data than the customary distribution ranges that are normally used. And one thing that I think it's important to consider is that those information that comes from model and help to build temporal baselines are central elements in conservation narratives, and conservation narratives are very important in order to inform policies and to push conservation targets and goals. I wanted to show the second case very quickly, if I have time. So this is a second study that we did with the wolf, also based on the information from Madoff from 1850, more or less. And the only message I want to send here is that depending on how you use the historical information, you can get very, very different results. So this is a paper published recently in Biological Conservation, not by us, by other authors, where they use the same information as we used later for modeling distributions, and they found out that already at that time the distribution of wolf was already highly reduced. So across Spain. So according to the results of this study, you would estimate that the reduction in the total range of the population is less than 50%. In total. And this number is very important because in Spanish legislation, the conservation status of the species depends on to what extent it has been reduced during the last 100 years approximately. Now, what is the problem? The problem is that historical data, even for data sources that have high density of observations, still are highly biased. And there are major gaps there. So you need to model distributions in order to be able to do that kind of assessments. We did those kind of models, and we used several different scenarios to estimate what would be the distribution of wolves in Spain by that time. And even in the more conservative scenario, in our models, we estimated that in reality, the total reduction of the distribution of wolves was around 70%, and most likely it is more. It could be something between 80 and 90%. Okay, I will skip very quickly those slides. I'll finish with only 3 open questions that I think are important in this kind of analysis of past species distributions. First, we still don't know very well how to account for the effects of differential spatial gaps and biases when comparing past and current species distributions. Yeah? So historical data is biased and have major gaps. In reality, a lot of the contemporary data also has major gaps. If you go to GBIF data, for example, you will find very similar patterns. So how can we match and how can we understand the differences between those two biases in order to combine the outcomes? First, it is still important to understand better or to better develop predictors of historical environment in order to match better the historical models. And finally, we need to discuss a little bit, probably in the next days, how predicted species distribution models can actually be translated into policy making and so on. And there are some ideas around that. Yeah, thank you.
Thank you. Sorry for rushing you towards the end. Do we have questions or comments for Néstor? Yes.
Thank you very much. I really, really enjoyed that. And the modeling that you're doing with potential distributions is fascinating. I'd love to chat with you more about it. But I have a baselines question, which is when we think about bending the curve, the policy baseline is quite recent. And so how do we reconcile? We can use historical information to have baselines from the past few centuries, but in policy terms, we're thinking about baselines from 1970 or even 2000 plus.
Yeah, the problem is even worse than that, is that baselines very often are not even defined in temporal terms. So like, for example, in the Global Biodiversity Framework, they decided not to discuss about 1 year for the baseline because that would exploit all the discussions. Yeah. So I think this is my very personal perspective. I don't know if everybody agrees about that. I think that historical data and this kind of models can help us to build narratives. I don't think they are so important for setting up like a specific baseline in 1 year, but rather to make people aware, and this is one slide I didn't show, but make people aware, okay, in reality, the perception that you have about the distribution of one species is based on your lifespan or maximum the lifespan of 1 or 2 generations, no more. Yeah. So in order to build those narratives, those restoration narratives, I think it is important to look at the past data. Not so much. When speaking about baselines, I am more oriented towards speaking about ecological integrity baselines and not so much on temporal baselines. We can discuss about that.
No, that's great. Thank you.
Yeah.
We actually still have time for a question.
Okay.
That's why I rushed you. Sorry.
So
Yes.
Thanks very much. My question's kind of baseline related as well. I'm just curious what it looks like in your experience. What does the lobbying process to get policymakers to revise an existing baseline look like? I'm referring to just the interaction of the scientific community and the policymaking community generally. Insofar as you've been involved at that interface, kind of what does it look like? How does one get a baseline, maybe that's even been codified to some degree in legislation, changed?
As I said just now, I think it's, putting a discussion around temporal baselines, I think it's extremely difficult. It exploits the process. If you are speaking about international agreements and so on, different countries immediately will come with different ideas because they will say, okay, yeah, you are putting the baseline in the 1500 because you screwed it up after that, but we screwed it up much more recently, so you are in reality penalizing us. Yeah? And in the case of Spain with this study of the wolves, in reality, that kind of baseline is already in the legislation. What was not clear is how to evaluate the status of the wolf according to those temporal baselines. Yeah, and this is what is when this kind of information can really help, in my opinion. I think, as I said, I think discussing about temporal baselines for setting conservation targets drives us to a non-end. I think we need to speak in terms of state of nature and what kind of communities would you like to have in one place or not, but not based on one specific period in time, rather based on the narratives that then you can use, like that kind of historical data and so on to build that. That is my perspective.
Yeah.
So how do we do that? because I struggle with this. I work on sort of historical reconstructions using different baseline to show how our interpretation of change or of processes changes if we use different baselines. And that's one element of the story. And the second element you're highlighting very nicely here is that we don't need to use those baselines to make decisions, but we need them as information, and we need to look into acceptance and human perception and so on in order to be able to influence policy properly and in a way that the society accepts it and so on. But how do you communicate that difference in a policy setting? Because that's something that I struggle with.
I struggle too, yeah. So if we are speaking in terms of research, I think one key research area where we really need to get much better is evaluating degradation and ecosystem integrity. This is something that we are not doing very well, yeah? So there is this concept of ecosystem integrity is everywhere in the policy documents recently. Still, it is kind of a scientific, the scientific community has pushed that concept, but we don't know how to measure it. And I think it needs to be defined in terms of how, looking at reference communities, and you can do it at present, not necessarily going back to the past. I mean, we have reference communities of well-preserved areas where we can, identify what would be an integral ecosystem from that, and then build narratives based on those in order to then define those targets. Yeah, but this is a very short answer for an extremely complex question that maybe requires more discussion. Yeah.
I take it. Thank you.
last one.
Yes, we have time for it. So I just wanted to comment on this exchange. I was recently, a little bit by chance, involved in the activities of the European Geoscience Union in the context of the nature restoration law. And I think, I mean, we were quite successful to the extent that the task force established by the EGU was asked in the end by the rapporteurs of the law, the MEPs, their assistants in fact, to propose amendments that would implement some of the scientific recommendations of the EGU. I mean, I don't think they will pass, yes, but I mean, it's really getting like, you know, they asked us in 3 days, send us how we should change the law, yes? Like, we are kind of hopeless, but we sent them something after consulting with some lawyers. But why it happened? It happened because there is a policy officer hired by the EGU. So it's not us scientists who had to do all the work. We were plugged in by her in some moment of the process, and we were instructed what to say, how to behave, what to do. So it's so complicated. And it's so, like, there is so much background knowledge that, like, we just don't have time to get. So I think what we should, from this small experience and some other that were much less successful, my feeling is we should really lobby to have policy officers. Like, people who really know how to do it, who really follow political process, and who, you know, like, grab us from the lab or from our desk. Now is the time, this is the moment in the process, this is the input you should give. Do not expect immediate reaction, and then they, you know, take us back to our natural environment. So I think it was incredible what was just achieved thanks to the fact that there was somebody really knowing how it works and doing it full time, basically hired, employed by the EGU. And it's quite unique, as far as I know, even for scientific societies. So I don't know how they came to that, but yes.
No, I agree. So there are, I can mention maybe 2 paths to influence in that. One is partner with organizations that are actually doing that, and there are NGOs. We are partnering with several different NGOs at the European level and so on. Second is incorporate even in research institutions those kind of expertise. And for example, in iDiv we do have a science policy committee where we try to, you know, push those kind of scientific results into the policy agencies, agendas and so on. So yeah, I fully agree with your point. Yeah, thank you.
Me too. Thanks.